Jai Hind everyone. My name is Anupam Kumar Saini, Assistant Professor from Akgec Ghaziabad. Today's my topic is Greenwich normal form. That is the part of normalization. In previous lecture, I also discussed about the CNF, Chomsky normal form, already discussed in previous lecture, and today is discussed about the Greibach normal form, that is known as GNF. We first recap of CNF. In CNF, there is a format of the grammar in which non-terminal derives the non-terminals, means more than one non-terminal, or in the form of single terminal. This is the form of CNF. And next topic is GNF. Before continue with GNF, we have to clear some topic that is known as recursion. Actually, what is recursion? We learn about the recursion in C and C language in first year, and most of the topic in data structure recursion used. Here, recursion means the function call itself is known as recursion. For example, if a language is A implies A, then if left hand side have the symbol that is also used in right hand side, then the grammar is known as recursion is here. If the grammar is written as A implies small a b, then in this grammar no recursion, because function not calls itself. And in here the recursion are basically two types, left and right recursion. If we derive the derivation tree of this, A implies A and implies A. If we derive derivation tree of this A implies A and A, and so on. This is a recursion. Basically, in this topic GNF, we have to remove the left recursion. So we first know about the recursion and how to remove left recursion. The grammar is written here: S implies S0, S1S and 01. Here S call itself, then it here due to S recursion is occur, and left the symbol at left hand side derives same as symbol in right hand side at leftmost position, then the recursion is left recursion. Here we have to remove left recursion with the help of following. If A implies A means a non-terminal derives non-terminal itself and a terminal symbol, then we have to remove left recursion. How we remove the left recursion? We replace this symbol in this form: A implies A, means here these symbols are known as alpha and beta. If we remove the left recursion, then we have to write A implies beta A dash, that new symbol A dash, and A dash implies beta, remaining symbol beta A dash slash epsilon. by this way we remove the left recursion. And what we do, how we remove left recursion in this? Then we have to write S implies 0 1 new symbol S dash implies the remaining production except the star symbol. Then we have to write 0s 1s s dash slash epsilon. So by this way we remove the left recursion from the grammar. Now come to our topic. This one is example of the another example in which we remove the left recursion as given previous question. Now our topic is Greibach normal form, that is known as GNF. If context-free grammar is in the form of A implies A alpha, where small a is a terminal symbol and alpha represent here a non-terminal symbol. Here alpha may be empty, means A implies small a can also be in the form of GNF. Means we can write it as alpha asterisk. This is also in the form of GNF, where alpha represents it may be empty or as required as the non-terminal symbol may occur. So in this form, if the production rule is written, then it will be in the form of GNF. Then there are three basic steps to convert any context-free grammar in GNF. Step 1, first we convert the given context-free grammar in CNF, convert it into Chomsky normal form. As we know that in Chomsky normal form, first we remove the useless symbol, unit production, null production. These productions should be removed in CNF. Then it convert in context-free grammar and convert it in CNF. Here we consider the grammar already in CNF. Step 1. If the grammar already in CNF, then no need to convert it. If it is not in the form of CNF, then we have to remove unit production, null production and useless symbol, then convert it into the context Chomsky normal form. Step 2, given non-terminals are separate naming. Step 2, here non-terminals are used in the context-free grammar, then we have assigned a new variable to that grammar. For example, here A implies ABC, then we replace A by A1, B by A2 and C by A3. For this way, give non-terminal as separate symbol. Then after that, we have to check that the production in the form of Aij, where I should be less than or equal to j, means this here if we write here this A1 implies if we take an grammar, we find the grammar with A1, A2, A3, A4, this type. This is the form of A1 is less than or equal to, means I is less than or equal to J. That is acceptable in GNF. But if the form in this form A3 implies A1, A2, means here I equal to 3 and J equal to 1, means I is 3, J is 1, where I is greater than J, and it should be less than or equal to J. Then we have to substitute these non-terminal with other terminals, other non-terminals, and find the this condition in which I should be less than or equal to J. Using substitution, we need bring production to the satisfy the condition, that is I is less than or equal to J. We see in the example. And step 3, eliminate left recursion. In previous we saw that the how to remove the left recursion. These 3 main steps are in GNF. First step is convert CFG in CNF. Second, separate naming given to the non-terminals. Third, remove recursion, left recursion. We take example. S implies AB, A implies BS, and B implies SA, and B implies A. This grammar is convert in GNF. The following grammar is, first step is convert it in CNF. The given grammar is already in CNF, so no need to convert it into CNF. Step 2, give separate naming to non-terminals. The grammar is S implies AB, then S assign as A1, B A, A2, B, A3. S is assigned A1, A is assigned A2, and B is assigned with A3. So we substitute these naming to the given context-free grammar. We get with A1 implies A2, A3, A2 implies A3 A1 slash B, and A3 implies A1 A2 slash A. Now check the condition AI should AI AJ, where I should be less than or equal to J. We have to check this condition, I should be less than or equal to J. Here I is 1, J is 2, it's okay. Here I is 2, J is 3, it's also okay. Here I is 3 and J is 1, that is not in GNF. Then we use substitution method for this, and we put the value of A1, from this equation. Then we get A3 implies A2, A3, A1, A1, A3, sorry, A2, this one is A2. We replace this A1 with this, we get A2, A3, A2. and substitute in A3, we get this A2, A3, A2, A. Now check the condition I is less than or equal to j. Here I equal to 3 and j equal to 2. That is also not in the form of I is less than or equal to j. Then we have to replace A2 with A3A1. If we put expression 1, 2 and expression 3, then we have to assign value of A2 from equation 2. Now substitute the production A2 in the production A3. Now we get A3, A1, A3, A2, A, B, A. This is the in the form of GNF, that is in not in GNF, in the condition fulfill I is less than or equal to j. Here condition is fulfill I is equal to 3 and j equal to 3, then condition satisfy I is less than or equal to j. But due to this A3 implies A3, left recursion occur, we have to remove left recursion in this production, because left recursion is not acceptable in top down approach. Remove left recursion in A3 implies A3, A1, A3, A2, A, B, A3, A2. Here alpha, this is alpha, remaining portion is beta. If you write it as a alpha and this one is as a beta, then if we remove left recursion from this grammar, we have to write this A3 implies A, A3 dash alpha, alpha and new symbol that we convert in the left to right recursion. Then this one new symbol we assign A, A3 dash remaining beta, B, A3, A2, B, A3, A2, A3 dash and A3 dash derive the alpha, new symbol A3 dash and epsilon. By this way we remove left recursion from this grammar. This production now in GNF. Now next step, we put these substitution in back in the production to find out our GNF. Then substitute A3 to the production A2, we get A2 implies B, A2 implies A, A3 dash A1, B, A3, A2, A3 dash A1, A, A1, B, A3, A2, A1. By this way we replace A2 and A3 dash in from our grammar and we get the production rule that is in the form of GNF. By this way we convert the context-free grammar in GNF. Okay, thank you.